Hey, hi everyone. My name is Varsha and welcome to Study with Varsha. So today we are going to learn about AWS DevOps Operational Monitoring Framework. This is very important for any DevOps engineer we have to know. So the first thing is I am going to, tell about what is infrastructure health and performance stressing, so many more things. So without any further delay, let's start. So first is executive summary. So this operational framework, what it will do, it will define a structured monitoring and governance model for AWS environment across development, staging, and production accounts. So the objective is to ensure high system availability, proactive security monitoring, continuously compliance validation, optimized infrastructure cost, control, incident response. So the framework integrates native AWS services along with third-party observability platform to build a unified monitoring ecosystem. There are some key operating principles. Centralized log aggregation using a dedicated monitoring account, automated alert routing and incident tracking, daily health validation across environments, continuous documentation, and RCA updates. So, this is all about operational framework. Next, first thing is what you understand by infrastructure health and performance tracing. When it comes about infrastructure and you know uh, health performance tracking, so there are too many things came in the picture. First thing is that if you're going to technical, it's like continuous visibility into compute and runtime layers ensures early detection of performance degradation. So core monitoring areas will be EC2 utilization in that CPU, memory, disk, input output, network throughput. Second will be container metrics, that will be ECS, EKS workloads, and serverless performance like Lambda, concurrency duration, and failure rate. Auto scaling behavior under load. So recommended practice is given like enable enhanced monitoring for production resources, track percentile based latency metrics. Percentile means percent voice. Configure anomaly based alerting instead of static threshold, and validate scaling policies in staging before production rollout. So if we are taking a real-time example, so in production EC2 CPU suddenly spike to 95% during peak traffic. So what we have to do, we have to check CloudWatch metrics and correlated with a new development. It turns out a background cron job, and that was running every minute, instead of every hour. So when we fixed the cron schedule and added an alarm to prevent the recurrency. So you can give this example. Now, application logging and observability. So application log must be structured, encrypted, retained according to the compliance requirement. Logging architecture. So dedicated log groups per services and environment, defined retention windows based on criticality, encrypted log storage using KMS keys, and real-time streaming to centralize analytics perform. This is about logging architecture. Now, focus on monitoring. So, error rate spikes, timeout anomalies, sudden log volume changes, and suspicious authentication pattern. So, let's try to understand this also by taking a real time example. Suppose users reported checkout failure in CloudWatch logs, okay, and that showed repeatedly 504 gateway timeout error from the payment microservices. So after log analysis, we found a database connection pool exhaustion issue. So we increased DB connection and added a log based alarm for timeless pattern. So are you getting? In this way, we can do application logging and observability. Now, third thing is network telemetry and access visibility. So it will comprehensive network logging is essential for security analytics and for scenic readiness. So logs to be centralized. How? So VPC traffic flows, DNS query logs, load balancer access logs, S3 object level logs, session manager activity logs, and governance controls with central S3 log archive with lifecycle management, strict budget policy with encryption enforcement, log segregation by account, region, and workloads. So let's take an example and try to understand. So real life example we are taking. So suppose GuardDuty flagged unusual outbound traffic. Now what you will do? You will do VPC flow log showed high traffic to an unknown external IP. Now investigation revealed a compromised IAM key used for the data exfiltration. So we revoke the key and enforced MFA plus key rotation policy. So in this way we can secure it. Now, resource optimization and operational hygiene. So, cloud efficiency directly impacted long-term sustainability, idle compute instance, unattached, stored volumes, over-provisioned instance type, underutilized load balancer, that is reviewed focus area. Now, come to the operational approach. So we can do weekly hygiene review cycle, snapshot before deletion, tag ownership enforcement, and track cost saving impact monthly. Try to take a real time example. So trusted advisor showed a multiple unattached AVS volume. For example, after validation we found they were from deleted test environments. So we snapshot plus deleted them and reduced monthly cost by $15, we can say. So this is also a good thing. Now, threat detection and security intelligence. So what it means? It means continuous threat detection across account is mandatory for modern cloud environments. So security control, multi-region GuardDuty enablement. Second is DNS and API anomaly detection, IAM misuse monitoring. Because of that, we should have to give least privilege to IAM. Now, cryptocurrency mining detection, incident handling, cross classification by severity, immediate escalation for high risk alert, regular alert validation exercise. So it means, like, for example, GuardDuty detected a brute force SSH attack on an EC2 instance. So immediately restrict port 22 access to the office IP range only. Now, then we enforce SSM session manage access instead of SSH. So in this way we can secure our service or server. 6. Compliance enforcement and configuration governance. So security misconfiguration often cause incident more than attacks. So automated governance means AWS config rule enforcement, organization-wide compliance aggregation, automated radiation via system manager, timeout bound exception tagging. You can take example public access restriction by encrypting enforcement, network boundary protection, and serverless network placement validation. So if you are talking about, we can take say like AWS config flagged an S3 bucket, okay, with public read access. Now it was accidentally exposed by a developer during testing. So we never block public access at account level and added preventive SCCP. So in this way we can secure. Now 7 is security posture management. So centralized security insights provide account actionable governance visibility. So there is some control monitoring, root account protection, IAM access key lifecycle, encryption posture tracking, public exposure detention. So high severity finding most trigger automated ticket creation. Now audit trail and API activity monitoring. So every infrastructure change must be auditable. Monitoring scope, IAM policy modification, security group changes, key management updates, privilege escalation attempts, enable anomaly detection for unusual API activity pattern. So in this we can understand, like CloudTrail showed a security group rule modified at 2 am. Okay, we can trail actually we use to know that like that is the API, so that we can understand who the person did whatever the activity, if you don't know the what is CloudTrail. So now CloudTrail showed a security rule modified at 2M. Okay, an investigation revealed it was done using a personal IAM user, so we enforced IAM role based access and restricted console access. So in this way we can do. Now backup, governance and uh, assurance. So backup are incomplete without restoration validation, protection strategy, automated snapshot lifecycle management, database automated backups with PITR, encryption S3, archival cross account backup, replication, conduct periodic store. So now 10, runtime standardization and version visibility. So operational consistency reduce technical debt. So Lambda runtime version, OS patch level, application version drift, container image vulnerability. So we will know today up to 10, and tomorrow we will learn more. If my speed is too fast, you can reduce my speed and you can read it. So thank you for watching Study with Varsha. Stay connected, stay tuned. Thank you.